Hey guys, welcome to Regents Chemistry, Unit 1, Lesson 6. We're going to learn about significant figures or significant digits. We're going to have these skills, these 4 skills. We're going to differentiate between accuracy and precision as a review from yesterday. We're going to state rules to determine sig figs. We're going to count significant figures. We're going to understand the importance of sig figs and converting between units of measure at the same time. All right, this is it. So just to go ahead and open up your note packet to page 16. You'll see significant figures right there up top. And hopefully everything is going well, guys. Don't forget to ask questions in class if you have any problems. Okay, so what are significant figures, or sig figs as we call them? It's a method of handling uncertainty in measurements. So when we do measurements, we measure them out to a certain level, but we'll be uncertain past that level of accuracy or precision, I should say. This arises due to the fact that we have different equipment with different degrees of accuracy, or, like I said, precision. Significant figures are associated with measured values. So anytime we measure something, are there any values that we don't measure? Certainly, there's ordinal numbers like the number 1. If you're just talking about how many items on eggs there are in a dozen, you'd say there's 12. It's just it's not a measured value, but how the weight of those eggs are would be a measured value. Now that means exact numbers are not included in this. So they do not count. We just don't limit our measurements based on that. You'll see what I mean. So atomic mass in the periodic table, a conversion, if they tell you there's 2.54 centimeters in an inch, that's the conversion. And then there's no amount of sig figs in there. There's this exact amount. Reading a ruler. Now this is actually tricky. A lot of people have a hard time with this. Not for any reason other than just practice. So let's look through it. What is this measurement? Well, we know for sure that the object is more than 2, whatever units they are, and less than 3. Do we all agree on that? 100%. Okay, we know for sure that the object is more than 2 point something. What is this number right here? So don't forget to be careful. This is 2.5678. So we know it's more than 2.8 even. So always start with the least precise conclusion, and then we're getting to the most precise conclusion, and we know it's less than 2.9. So we are pretty confident with this level of precision. Now, we're going to always finish our measurements with an estimate. Our last digit must be an estimate. Now, I would say right here is like right around there. That little tick mark represents our last little measurement, right? So I'll make it green. I believe, and this is where it's an estimate, it's less than halfway between 2.8 and 2.9. So I'm going to say it's like 2.82 or 2.83. You would not be wrong for putting 2.82. I would probably say you're wrong for putting 2.84. Really, to me, my best estimate is 2.83. And that is how we read this ruler. All right. How about graduated cylinders? So you might have, what is a graduated cylinder? You might have seen these in the lab already. It's it's going to be those cylinders that have graduated lines in them. Redraw that. There's a little spill cup there. It has a long vertical column. It has a wide base. Okay, and then it has little tick marks all the way across here. And that's what a graduated cylinder is. When you're measuring it, water, you'll see, forms a meniscus. And you're going to always read the bottom of the meniscus. Another great name for a band. And that will give you the reading of, in this case, what is the reading? Well, we know it's between 25 and 30, so don't even give me anything beyond that, or above or below 25. Okay, it has to be above 25 and below 30. And then we look over here, and if this is actually 30, there's these little tick marks. And then what does that mean about this number? Well, these must be units of 2, 4, 6, 8, if that makes sense. And this is about halfway between those. And so this would be 220, oops, oh my gosh, 25, and, oh, not 25. This is 25, 26, 27, 28, 29, 30. So 27. Now, I'm pretty sure it's 27, but how far are you going to say? I think I can go only as far as 27.5. All right, 24, 26, 27, 28, 29, 30. So I know it's 27, and it's about halfway between 27 and 28. All right. There's this method. You're welcome to use it. I'm not going to talk about it in class, or unless it's to help people who are trying to use it. I'm going to go through here and identify significant figures. And by doing that, I think you'll be able to figure it out. I think this method is harder to learn than the actual sig figs. Let me just show you what I mean by that. You're not going to read trailing numbers, trailing zeros, unless they're part of a measurement, like in this. And we're going to count the digits or figures that we have in our measurement. So if I say something is 357 units, that means it's 3 significant figures, so 3 significant numbers. If I says it's 3,570, no, this is key. No decimal point. There's 3 significant digits in that number, because the only ones that matter, are those first 3. If there's no decimal point, that means there's no saying that that is an actual measurement. It's exactly 0. If we mean that it's 3,570 and not 3,571, then we must put a decimal point there, which makes it 1, 2, 3, 4 significant digits. Now for this one, you'll see it's 0.357. The leading 0 does not count. Okay, the 3, the 5, and the 7 are the significant numbers. There's always a 0 in front of a number with these decimal types, so you don't have to count them. How about here? Leading zeros don't count, so we're not counting those. 3, 5, 7, it's still 3 significant digits. How about this one? Well, the 0 is after the decimal, so we will count it. So this will be 1, 2, 3, 4 significant digits. This will be 4 significant digits. Now, feel free to apply what I learned upstairs, but I really believe that it's not too bad, just you need some practice. But rules help, and these are the rules. Non-zero numbers are always significant, true. Zeros located between non-zero numbers are significant. So for example, that is definitely the 0 significant, so that's 3. For numbers less than 1, oh, you know what we should do is just keep practicing. So how many significant digits here? There's going to be 9. How many significants here? There's going to be 3. Zeros between non-zero numbers, remember that's 3. As long as it's between 2 non-zero numbers, those all count. That's 5. Leading zeros for numbers less than 1. Zeros to the left of 0, they don't count. Only the numbers that are following it do. So that's 4. There's 1 there. Well, not 9, there's 1. All right. Zeros at the end of a number. If you put them after, it means you've done a measurement that says it's 85.00, not 85.01. It means there's 4 significant digits. If you put it after a decimal, each and every one of those count. That's 3, 4, 5, 6, 7, 8, 9, 10. 10 significant digits. Zeros at the whole number may be significant or not. It's uncertain. Depends on a couple of things, but to be absolute certain, this would be 2. The number's 2, but that's 1 significant digit, and this would be 4 by the rules. Exact numbers, that's an infinite number. So they don't count towards it. All right, which rule do we use for 1020? Well, first thing is that we have non-zero numbers always significant, so we use that one. How many significant figures, by the way? There's 3 significant figures. Now, we also use rule 2, which is zeros between non-zero numbers are significant. We use rule 1, non-zero numbers are always significant. So we're always using 1. But we also use rule 2 here. And then rule 5, that zeros at the end of a whole number may be significant or not. If there's a decimal, they are, and if there's not, it's not significant. No decimal, so we had to use rule 5 to figure that out. All right, I'd like you to try these. Pause the video, work your way through, and unpause it when you're ready to go over it. All right, 2 significant digits here, 4 significant digits here. This is actually 6 significant digits, 1 significant digit, 4 significant digit, 5 significant digits, 3 significant digits, 5 significant digits. Make some more room. And this is just 3 significant digits. What are the rules applied? We have, of course, 1 and 5. 1 and 5. Again, 1 is just non-zero numbers, and 5 is zeros at the end of a whole number. So I don't think that's very bad. And this would be those decimals, 1, 4, and 5. Other rules we used, 1 and 3. 1, 4, and 5. Trailing numbers as well. 1 and 5. 1 and 3. 1 and 2. And 1, 2, and 5. All right. How about using them for significant digits and calculations? Well, it seems this is the key part because you'll be doing this in every lab. So how do we calculate them? Well, this one has 5 significant digits, and this has 4 significant digits. When you multiply numbers for multiplication divisions, you always go with the least significant digit you are given to. So our answer has to have 4 significant digits. That's the key idea. So our answer might be 14.242634, but we're going to only have to write the first 4 significant digits. So the answer will be 14.24, whatever units it is, but that's 14.24 is the answer with 4 sig figs. With addition and subtraction, if you use a really exact tool, but then you don't use a precise tool after that, you'll lose all that precision you've gained from the precise tool. So you take the least significant digit over there to like the tenths in this case. The tenths is the least significant digit. So when you add this, you're going to get, if you did the math in the old days, remember 22.0429. But then you added all these up. What's our actual answer? Well, we can't be more exact than the least measurement. So it's 220.4. We just round that last number. So it's 220.4. All right, take a look at these. Try these examples. Well, I'll do these examples for you. It's subtraction. So you subtract these numbers in your calculator and then round it to how many, well, you can't go beyond the tenths hundredths place. So our answer goes beyond 2.84, but we round it to just 2.84. We round it to the hundredths place. All right, and the next one, same idea, we divide, but this number, we go with the least significant digits, it's 3. So our answer goes out farther, but it's 1.51. So to 3 sig figs in this case. And you'll hear me say digits or figs, they're the same idea. Here's the rules for calculating scientific notation. This might be useful for you when you're doing the practice packet, which brings up the practice packet. Let's start that. Let me close this, open this, and let's take a look at it together. I think we start right here. 15. So we already did that one yesterday. This is 15. Okay, significant digits. I feel like we've just done it, so I won't do too much. But let's get started. Decimals, significant digits, decimal present. Oh, okay, this is actually simpler than I thought. Definitely there's a decimal present. Significant figures, 4. Decimal present, no, it's absent. How many significant digits? 4. All right, I'm trying to think of a tricky one. Let's take a look at 15. Decimal present, yeah. Significant digits, 5. All right, let's move on to the next page. How many, we've just done this, so I'll move on. Why are significant figures important in a laboratory? These are the good questions now. I like this. Because when you're measuring things, which is what you do in labs, you measure volumes and all sorts of things, it helps you have a proper level of accuracy. All right. Why are significant not important when solve problems in your math class? Because in math class, they don't always, this is actually not true. This is not true. I don't know how to say it. I don't like this question because in math class, figs are really important as well. Because in the word problem, they'll tell you whether it's a measurement or not. Anyway, the reason why they'll say it's not is because sig figs are used for measurements. And the last time I checked, we do make measurements in math class. But I'll leave it at that until that got me riled up. 2 different instruments that measure the length of foot to be 27 centimeters and 27.00. Explain the difference between the two. This number 27 is more precise. And this is more, what did I just say? This one is more precise. So it keeps you the level of precision and protects your accuracy. Less precise for sure. All right. Solve each problem. Let's do one. Let's do 2 of them. Let me do number 15 and 14 with you. All right, number 14, you're going to subtract those 2 numbers. And you should get 31.57. 31.7. But here's the issue. Is you have to take the least. It has to round to the 10th. The reason it's the 10th because the 10th is the least precise measurement. How about number 15? This is a division problem. So you plug in your calculator, please do, and you'll get your number. But you know it's a division, which means multiplication division. They limit to the least number of significant digits, which is 3 for each problem or each measurement. So it's 4.58 is our answer. All right, how about these? Same idea, solve each problem, express the number of significant figures. Let's take a look at this one, 3.2, 4.0. Add those up in your calculator. You won't get this as an answer, you'll get something larger, but you'll round it to 26. The reason you round it to 26 because the 1's value is the least precise measurement, and that's why you have to use nothing more precise than 1's value. All right, same idea here. I mean, there's some difficult ones I'd like you to try, and that's it. All right, that's your homework. Have a good day, and thanks for working with me.